We're going to talk a little bit today about the tools that are built into Solid Edge from an electrical routing perspective. And what I want to do is give you a heads up as to what we're going to talk about today with the agenda. Before we do that, though, I wanted to, again, thank you for your attendance today. Over the last couple of webinars, we focused on different process-specific applications within Solid Edge. We've talked recently about frames and weldments, visualization tools, and today we're going to talk a little bit about the electrical routing tools, both from an electrical schematic perspective as well as wire harness within 3D assemblies. As I mentioned, the demonstration today will focus, we're going to start off talking about the 2D applications with 2D schematic applications and diagramming, and then we'll move into tools that are built in for 3D wire harness for better visualization, and then how do we take this information from a manufacturing perspective and generate the information that we need for the wire harnesses to be manufactured. With that, I'm going to go into Solid Edge. We'll do a live demonstration today and talk a little bit about these tools. As most of you who deal with electrical routing or electronics within your products may know, oftentimes the wire harness information may start off in a very simple 2D schematic diagram. And Solid Edge has those tools built in. You'll notice this particular schematic may be maybe a little fancier than what you're used to seeing in regards to many of the block information and connections have different colors, a little bit more bold and maybe a little bit better from a visualization standpoint. And Solid Edge has a lot of tools that allow you to create not only the 2D block information, but be able to apply colors, different line types and line widths for better visualization of what you're looking at here in the schematic. You'll notice that Solid Edge also has a built-in library of different block information, whether you're dealing with electrical blocks, or maybe you're doing a schematic for piping applications or other mechanical applications. Solid Edge has many, many different industry standard blocks that you can utilize and bring into your schematic. If you click on any block that's located over here on the left-hand side, you'll get a preview of it down here at the bottom window, and then it's a simple drag and drop onto the schematic. You can lay it out wherever you'd like, and I'll show you some examples of that here in just a minute. You'll notice we have some components that are laid out on our schematic drawing. If you click on any component or any 2D block, it'll tell you which block you're referencing up here in the top at the top of your screen. And then same thing, if I select any of the connections, it does the same thing. It tells you what type of connection you're utilizing, in this case a jump, what the end conditions are as to what it's connected to, and you'll see many different options here that you can specify when you want to place both the components as well as the connection information onto this 2D schematic. Just as a quick example to show you how I can connect, you'll notice that I can reference elements off of the components, very much like any other 2D sketching application within Solid Edge. It gives me feedback when I'm touching elements or if I'm connected or in line with other elements, so that I can make sure I'm creating those connections very quickly and very accurately. They're also smart connections in the sense that as I take this jump connection, as soon as I get close to another wire, it'll snap to that wire and maintain that associativity. So as I start to make edits to the locations of the wires or to the component relative to the 2D blocks, those stay connected and we'll move with it. As an example, you'll see here as I decide to move some of this block information, notice all the wires that are connected there are going to automatically adjust with the new position. You'll also notice that many different companies are utilizing just standard 2D tools that are out there on the market today. In this case, I have AutoCAD file. It's in DWG format. Solid Edge will recognize block information that's inside of the AutoCAD file. So for example, as I select this particular AutoCAD file, it shows me any block information that is stored inside the DWG, and then I can reuse that information just by simply selecting that, dragging it out from the library, and then placing it onto my 2D sheet. If I want to document the information as far as the blocks are concerned, Solid Edge has a block table, and it'll allow me to select all the blocks and then reference a table that calls out specific information. In this case, it'll number each of the balloon items with balloon item numbers, tell me what the block name is, and then how many, specifically how many blocks of that specific component are resident inside of my schematic drawing. As I mentioned, the schematic tools that you're seeing here today, they are built into Solid Edge. They're actually built into the free 2D drafting application that anybody out there can go to our website and download. So if you do 2D schematic work, maybe in AutoCAD or any other type of tool, and you're just laying out 2D information, I would highly invite you to try out the tools that are built into Solid Edge and allow you to create the schematic diagrams very easily. We're going to flip over into the Solid Edge 3D application and show you how some of these tools can be utilized for better visualization and creating 3D wire harnesses. As we look inside of this bulldozer cab, as I rotate this cab around, you can see just very quickly that we do have some wire harnesses and some routing applications built in. As we kind of zoom in a little bit inside the cab, many different tools, many different functions of the bulldozer cab that's going to require some electrical componentry. So on either side of the operator's chair, you can see we have some different controls. If you look towards the back, you'll notice some other switches that are going to require some electrical work. The ignition, the radio. If we kind of tilt up to the top and look up above the operator's head, we have some light switches here on either side. So just, you know, there's a lot today, the trends in the marketplace today where, you know, the electrical engineers kind of work by themselves and do their job, and then the mechanical engineers are working on their applications, and then they come together downstream. You'll notice with the sophistication of many of the products today is there's going to be a lot of electrical work that needs to be associated with your mechanical components, and those teams have to work very, very closely together. So we're going to show you some applications here and how you can accomplish that very quickly and very easily here inside of Solid Edge. I'm going to change the display and turn off some of the outer components so that we can see a little bit better some of the applications, some of the routing underneath some of the outside shells of the components. So as I turn off some of the outer body, you'll notice here we have a number of different connectors, a number of different wire routes. If I go over to the other side, you'll see the same thing. And you'll see we have some smaller routes, some smaller cables that go into larger cables here. And Solid Edge does this very well, and we'll show you some of the applications on how that's accomplished here in just a few moments. You'll also notice along the inside structure, this is covered up typically by those outer panels. We have some wire holders, some traps here that we want to have the wires from the top of the cab run down alongside this vertical structure here, and we'll show you an example of how we're going to utilize those here in a minute. We'll flip the configuration again just to see some other componentry, just to give you a little bit better visualization of where we're going to go here in a couple minutes. But we're going to create the wire harness for the lights up here at the top of the cab. Again, have those run down the side structure here and show you how we can utilize those existing 3D models to route your wire harnesses. Let's just look at the top of the cab, and we'll see that some of the routing has already been done, and we're going to go through and create some additional wire harnesses and show you a couple of different methods for generating the wires, the cables, the bundles, and the things that you see here on screen. We're going to go into the subassembly that represents the cab lights. And you'll notice here, as I mentioned, we do have some components that exist out there, some existing wires. I want to draw your attention to the different types of connectors. The connectors can be modeled from scratch utilizing Solid Edge modeling tools. You can also download these connectors from vendor websites or from popular websites such as GrabCAD and others out there that if you want to take an existing connector and utilize that inside of your solid edge assembly, you can do that very easily. If I go into our wire harness application, you can get information off of those connectors very quickly. For example, I can show the connector information just by simply tagging the connector itself. So it'll tell me, for example, the name of that component, what it's designated as, and then also all the different terminal information. I can do the same thing here for this other connector. There's another connector represented over here, and I can get that information just by simply tagging on the connector itself. If I tag on it again, it turns that information off. So what that allows me to do is, as I'm routing the wires, either automatically through our wire harness wizard, or if I wanted to route those manually with some of the other tools that are available, I can make sure I'm selecting the right component and selecting the right terminal information right from the start. Let's zoom out just a little bit. We'll show you an example. There are many popular ECAD systems out there on the market today, and we can utilize the information that comes from those ECAD systems directly inside of Solid Edge. And we'll do that via the Solid Edge Wire Harness Wizard. As I go into the wizard, you'll notice that we have popular ECAD systems, for example, Bentley, Zuken, Mentor Graphics, and there are others that we work with as well. But what we're able to do is we can take the net list information, which is basically what components am I connecting and with what connections. And I can take that information and utilize that inside of my Solid Edge assembly. So as an example, I want to take maybe from Mentor Graphics or from Zuken or some of the other tools out there, I may want to come and select the information for all the different components that I'm going to be utilizing. And as I select that information, it shows me and gives me that feedback as to what files I'm utilizing. Also the connection information, what wires, what gauge, what color, all the information associated to that wire information is inside of this XML document. When I flip to the next screen inside of the wizard, it shows me those components that are going to be connected. It shows me their unique ID, their component name. This information we just saw graphically on screen when I selected the component information. It also tells us the component description and whether or not there is a 3D model associated to that connector. And you'll notice that there is one connector that's not represented here graphically in 3D. And whether that was an oversight or we haven't filled out that information yet, it gives us that automatic feedback that it's not sure which connector this is and how it's going to tie it to the 3D model. What's nice about Solid Edge is I can select the one that is not populated yet and assign any connector inside of my Solid Edge assembly. And now it knows that this connector is the DT06-2S component. When I go to the next section in the wizard, this is going to give me all the information relative to the connections. So what the wire name is, and it also tells me where it's coming from, both the component and terminal number. Also which component it's going to and its terminal, and then also a description about specifically what type of connection this is. It gives a description, and then it also gives me the attribute. So specifically, is this a 16 gauge solid copper green wire, or is it one of the others listed here? If you wanted to change it on the fly, you have the ability to do that just by going to the drop-down menu, and then you can change which connection type you have here. If I want to see a preview of these wires before I actually have them created, there is a preview option here, and you'll notice as I zoom out, it'll show us the preview of those connections and where those are going to go to. As I hit finish and complete that, it'll then actually take the specific attribute information for those wires and connect them relative to the net list information that we just saw. As I zoom in on any of the wires, I can go to their properties. For example, this is a 16 gauge solid copper red wire. It tells me what its diameter is, what type it is it solid, stranded, what material are we utilizing. It also gives us information, that connection information we saw in the wizard. And then over here on the right-hand side, it shows us some information that each company or each user can customize based on your standards. So if you wanted to put added length, you can go ahead and fill in that information in. You can also do slack percentage information. And then you also notice there's a computed section where it'll calculate the length of the wire based on their position in 3D space and where those connections lie. And then it also calculates the mass of the wire based on its length and based on the properties that we see over on the left-hand side. So obviously, this information is very critical. You think about how much weight a wire harness can add to the total weight of your assembly, and the fact that it'll calculate all this for you and give you that information is very, very important. Right now, these wires are just represented as 2D representations. You'll also notice that the wires are essentially floating in free space. They're not really positioned exactly where we want them. They're just going from point A to point B in this case. But we may want to place those specifically. Maybe we'll talk about how we'll place them here in these clips specifically. So I'm going to zoom in a little bit tighter here and show you how we can add some additional information to our wire harness. In this case, I'm going to grab the cable command. I want to generate a cable and place these wires in the cable, and I can do that very easily. And at the same time, where does this cable reside? And what I can do is simply reference the existing geometry of these clips here. And I just simply tag the geometry, and it's going to place this cable and route it automatically through the geometry that I select. And we'll have the wire come out here, maybe come out here to the left just a little bit. And then specifically, what type of wire do I want to create? In this case, we'll do a stranded copper gray wire. And as I hit finish, you'll notice that it'll take all of those wires that were previously floating in free space and route them exactly where I wanted them. Now, because we were looking at this more from a front side view, you'll notice that here in the back side, it didn't really pay as close of attention as to how those were routed from the side view. And I did that purposely to show you some other feedback and things that Solid Edge will do for you as you're going through the design process. Now, obviously, you can set up, for example, minimum bend radiuses. You know, obviously, you don't want your bend radius to be too tight, because that can affect the circuitry or the signal that you get from the wire. You may want to have a minimum bend radius. Same thing with other applications where you have to have certain rules in place. And what Solid Edge will do is it'll give you graphical feedback if you have violated any of those rules. In this case, I'm violating a minimum bend radius, and it gives me graphical feedback here as I put my cursor relative or near that harness. And then also over here in your Pathfinder, it'll put a gray arrow next to any connection that has been violated. So in this case, these 10 or 11 wires or so have that gray arrow. All I have to simply do is just click on that connection point and say I want to just modify where this is in 3D space. I just simply click it, drag it over closer to where it needs to be, and you'll notice as I let go of that, those gray arrows disappear. I no longer get that violation symbol, and I've got my wires located exactly where I want them. Now, the 2D representation of the wire harness is nice, but for better visual feedback, I'm going to right-click and say, let's create a physical conductor, and you'll notice that it'll actually place the actual diameters on each of the wires as well as the cable, and I can get better graphical feedback on that and see exactly what that would look like and how it's routed and get that information. Now, it's nice to be able to utilize that information and route the wires utilizing the data from the ECAD system, but as many of you guys know, also with any project, there's going to be changes that need to be made. I may get a portion or a different cable or wires located where I want them, and then we need to adjust the location of different components, or maybe I need to come in and add some other components. Maybe I have these additional wire holders here that I want to route an existing wire through. So what I'll do is we'll go ahead and relocate an existing wire here, and we'll go through and show how that can be done very easily. So very similar to what you saw me do prior to making the 3D representation is I can also come in after it's in 3D and just simply drag it closer to where I want it to be. You can do kind of eyeball this, or to be more precise, versus just kind of putting it in a rough location. To precisely locate it where I want, there's also this tool called route. And what the route tool allows me to do is simply select the cable and say, let's route that through these components here. And it'll automatically and dynamically update those and route those exactly where I want them precisely. Also, you'll notice I have a couple of wires that are kind of freestanding. They're connected where they need to be, but maybe I want to reroute those through an existing bundle. So we have tools, for example, that allow you to split the path. And maybe I want to split this path here, and gives us feedback that that path has been split. And then I can also come in and say, well, let's also take this blue and orange wire. We want to bundle that to an existing path. And we'll go ahead and take it and bundle that through this path here. Now, what you'll notice is currently the diameter of this bundle is a specific size, but if we add 2 wires to that, that obviously needs to grow and get larger. So again, Solid Edge will automatically increase the size of that bundle because we've just now added 2 wires to it. So again, it knows what information is flowing through this portion of the route, and it knows that that needs a larger diameter. Now, let's say, for example, you don't get information from an ECAD system. You're working directly inside of Solid Edge, and you want to be able to create wires and bundles and cables just utilizing built-in tools. And you have the ability to do that as well. So if I come over and select our wire command, you'll notice that I can come in and just utilize just manual means to connect one connector to another. So as an example, I'm going to come here and select the connector to this red wire, and I know that it needs to be connected over here to our lights, and we'll select that point. And then as I do that, I can specify the specific wire type that I want, very similar to what we saw earlier with the ECAD data, but now I'm just selecting this manually. In this case, a 16 gauge solid copper red wire. In the same manner, we'll do the very similar approach to the black wire. We'll take, let's say, this element here, this connector, and we'll bring it over here and connect it to another terminal. Let's say maybe this one here. And maybe this time we'll make it a solid copper black wire. And very similar to what we did before, let's go ahead and show this as a 3D representation just for better visualization. So as I zoom out and look at what we've done so far, you'll also notice that some of the other work that we've done, it's very simple, very easy to be able to say, okay, I know it needs to go from this connection point to this connection point, but now that the wires are created, just like you saw me do a couple minutes ago, I may actually want to take these wires and route them through an existing bundle. So again, as you saw me do before, I can take our bundle feature. This one's a little bit more complicated. It's not as straightforward as the other one, but you'll notice I can take both the black and the red wire and say, let's go ahead and route those through not just one section, but let's route this all the way around these 5 different sections. And what you'll notice Solid Edge do for us is it'll take those 2 freestanding wires and now reroute them all the way around to where they come out this end, but still stay connected where we told it to earlier. So again, very, very flexible tools to get your wires located exactly where they need to be and added to an existing bundle. And then for documentation purposes, you'll see later on that those wires are going to be exactly where they need to be and documented correctly. Let's turn off a couple of components. Let's show a couple of other tools that are available here within Wire Harness. And as we look over here, again, where these lights are located, sometimes you may want to splice a wire, and we have tools that allow you to do that as well. So you'll notice up here we have a Splice tool, and I can splice, an individual wire, or I can splice multiple wires. But in this case, I want to splice this red wire, and then exactly where is this splice going to be located. And we'll just place it right here at the end of that. And you'll see you can have different types of splice, whether it's a barrel splice or a butt splice. or an ultrasonic welded splice. And again, you can go ahead and fill out this information and customize this. But we'll go ahead and do the top option, and it'll go ahead and splice that wire. And then that'll give us the ability to add another wire here to it. And we'll do that very similar to what we did before. So we'll select that red wire, and we'll just add it to where the splice is located. And as we select the endpoint here, we can get our quick pick to get this exactly where we want it. And what I'll do is I'm going to change its location. Again, we have controls here to change the direction or the tangency right as it's coming in or out of the splice. And we'll just have it come out in this direction. And in this case, we'll change this to a 16 gauge solid copper red wire. Now, oftentimes too, when you're generating or creating wires, sometimes these are purchased components. So you'll notice in this case, maybe I know that this has to be a specific length. So we can come in and edit the wire. So in this case, I know that I want this to be a specific length as an example. So I can come in and go to its properties. So whether I'm here in the properties, or if I'm coming over and wanting to change the location, I can do that. Let me come in and actually select the appropriate option here, in this case the path. We'll edit the path information. And here within the path information, you'll notice that there's an option here called curve length. So if I click on that, exactly what do I want the length of this wire to be? So if I click on fixed length, maybe off the shelf this comes in maybe 50 millimeter increments, and I'll make this 400 millimeters, and that'll keep that fixed at that length. What that does is if any components that this wire is connected to, if they change position, if they move, if they get repositioned in any way, shape, or form, then those will automatically maintain the length of that wire. So you'll notice here as I drag these 3D components, notice how that wire automatically updates and maintains its length, but it'll update its shape to maintain that fixed value. And you'll see that automatically update. I'm going to show you one more thing here to kind of wrap up the options. I'm going to hide a couple of wires here and hide a couple of other pieces of information. And let's look at this. Let's look at a couple of other components. And we'll look over here, here on the back end. I wanted to show you just one thing, maybe you can think out of the box on this one. If you have some standard components that you might want to look at, maybe I have a standard connector or some standard options here where I have a couple of connectors and a couple of wires that maybe it's the same type of connection, maybe just different lengths, and it's maybe part of a standard connection in my library that I want to use over and over again. So as I drag this particular connector out of the library, again, you can see it has 2 connectors on the ends and it has 2 wires. And this one has been what we call capture fit. It knows how it gets placed. I just have to tell it where to go. So we'll select the geometry for where this needs to reside. And it'll place that connector in there. And I think I selected the wrong location for that, which is okay. Let me come back to that and see what we selected there. And let's go back and assemble that last piece. So we'll come back here. We'll select the top portion, and let's place it where it needs to reside. In this case, we'll select the proper face. And I had selected the wrong face earlier. But what I wanted to draw your attention to is, this is a specific length. We want to go ahead and make some modifications to this. And just for sake of time, I know we're running a little bit short on time, but what we would typically do is go through and just replace this particular connector with a copy, because we don't want to override the original. We're creating a new connection, and it's going to be a new part number. And what we have the ability to do in Solid Edge is we can take that connector and we can make modifications to it utilizing synchronous technology. The other end of this connection needs to reside over here. And what I can do is I can take this standard connector, just simply drag it closer to where it needs to be, and notice how the wire length automatically updates. And then if I wanted to, for example, maybe take this and maybe rotate it around 90 degrees because it's going to reside or be connected in this orientation, again, you'll see the wires automatically update. And then I can go through and just assemble these exactly where they need to go. You'll notice I'm working within this connector subassembly, but what's nice about Solid Edge is I can still reference geometry from another assembly. Just by simply holding down my Shift key, I can start assembling this exactly where it needs to go. And we'll go ahead and just finish out the assembly. Select the appropriate faces. And then again, we'll reference geometry from another higher level assembly and place that where it needs to go. And then we'll do the same thing here. Maybe offset that from this face and get that exactly where it needs to go. And again, Solid Edge will automatically update the position and the length of that wire. And very similar to what we saw earlier, even though I'm working within this subassembly, what's nice about this is I can tell Solid Edge, you know what, let's go ahead and route this wire. I'm going to go ahead and show the wire. And then that'll allow me to come in and route this wire through the appropriate locations. And again, that'll update automatically. All right, let's quickly go back to our 2D information. Again, I wanted to show you that you can place standard drawing views in your 2D for 2D documentation purposes. We can come in and place standard views to kind of show where these wire routes are. But for manufacturing purposes, what we may want to do is come in and create what we call a nail board. And what that'll allow us to do is take the lights information and place those in what we call a flattened view, so that we can get information on the connectors and get this documented for whoever's going to be assembling or creating the wire harness. You'll notice here I can move the wire harness information. I can do things like add bins if I want to relocate the position of the wires. We have other tools that allow us to create connector views, and I can do that very easily as well. And show the connectors that's going to be relative to these wires. And then very similar, I can show the information relative to those connectors. I can create a connector table, and that'll document all the information of what's in that connector, the pin numbers, the wire IDs, which color. And then very similar, if I want to create a conductor table to show all the information in the wire harness, I have the ability to create that information very quickly as well. You'll notice here that it shows all the different wires, cables, bundles inside of this wire harness. It gives me information such as wire ID and all the other information that we've looked at, including the cut length as well as the true length. So I'll know exactly how much wire I need, and it gives me all that information back. So again, I know we ran over just a little bit longer than expected. At this point in time, I'm going to go ahead and turn it back over to Mary Ann, and she'll wrap up the webinar for today. Thanks for your time and attention.